Hello, this PPT explains stochastic process. As it was written in the table of contents, it will be described in order of introduction, definition, applications, and reference. Let me introduce myself first. My name is Yoo Hye-rim. I graduate from Keimyung University. My major is statistics. Currently, I am studying a master's degree to learn more about statistics. The addresses on the right side of the PPT are my social network accounts. The following is the definition of the stochastic process. A stochastic process is a collection of random variables indexed by a variable t, usually representing time frame. The variable t could be defined as an infinite number of points. The probability variables that are realized at each point can be defined indefinitely, such as random walk, Brownian motion, etc. For example, in a time series model AR1, stationary, random walk, and explosive process can be divided according to the law. We have x1, x2, x3. AR1 model xt equal law xt minus 1 plus epsilon t. 1. Absolute law is less than 1 equal AR1 stationary. 2. Law equal 1 random walk. 3. Law is bigger than 1 explosive process. Now let's look at the usage model created using the stochastic process. There's usually random walk and Brownian motion. The first random walk is the simplest form of the path generated by the following rule. It's the starting point. The path is distant from one side to the next. The path is selected in one direction from any direction. Because of this, random movements are irregular. For example, xi equals the prize money when you draw the ITH coin is definition as follows. Sn equals x1 plus x2 plus ellipsis plus xn. S0 equals 0. xih equals 1. xit equals minus 1. At this time, Sn is referred to as random walk. In random walk model, it is assumed to be S0 equals 0, rho equals 1, epsilon t follow IID. The following formula. Variance depends on time t. Variance xt increases linearly over t. On the average, random walk model returns to 0, but it takes infinite time. Next, Brownian motion. Liquid molecules constantly collide on the surface of an object in a liquid. Collisions of these liquid molecules are irregular and uneven, but statistically equivalent if the surface of the object is wide. Therefore, large objects no longer move when they reach their mechanical equilibrium in a liquid. However, in microparticles with a small surface, the impact becomes more disproportionate, and the effect of the microparticle can cause the object to exercise irregularly. For example, if you put water in a cup and unwind the ink will mix as if it were tangles and then mix later. Brownian motion is one of the most important processes in probability theory itself. Suppose that x1, x2, x3 is a stationary sequence of random variables with finite variance sigma 제곱 and a common mean mu. The partial sum process is defined by S2nt equals Snt minus Nt mu. At this time, t is between 0 and 1. Functional central limit theorem say that 1 over root n S2 nt follow sigma bt, where sigma star 제곱 is equal to sigma 제곱. B is the standard Brownian motion on 0, 1. At that time, follow the formula flow. Thus, the probability of Brownian motion is 1, in no case differential, and the following expression is established. For example, Si equals epsilon 1 plus ellipsis plus epsilon I, and Sj equals epsilon 1 plus ellipsis plus epsilon I plus ellipsis plus epsilon j. So, Sj minus Si equals epsilon j plus epsilon j minus 1 plus ellipsis plus epsilon I plus 1. Also, variance Si equals expectation xi square equals I. Variance xj equals expectation xj square equals j. Variance Sj minus Si equals j minus I. Therefore, B0, 0. Expectation Bt minus Bs square equals T minus sigma square. Expectation Bt minus B0 square equals T sigma square. Bt minus B0 and 0, T minus S sigma 제곱. Also, T1, T2, T3 Brownian motion at T1 and T2 is independent, and what follows is largely independent compared to what appeared in the front. Finally, it is a reference to making PPT. This concludes my presentation. Thank you.